What if everything we think we know about the laws of physics, space-time, gravity, the arrow of time, what if they aren't fundamental truths of our universe at all? What if instead they're just the result of a massive computation that starts from the absolute simplest ingredients imaginable? Well, today we're diving into a fascinating new theory called DASHI, which says exactly that. Let's walk through how it claims to build our entire reality right from the ground up.
So this is really the heart of it, isn't it? Instead of assuming all the complex laws of physics and working forward, DASHI completely flips the script. It asks us to start with almost nothing, apply just a few incredibly simple rules, and then see if our universe is the only possible thing that could be computed. It's a pretty radical idea, and honestly, it's a fascinating one.
So to see how you actually compute a universe, we're going to follow what DASHI calls a Ethereum pipeline. First, we'll look at the primal alphabet of reality. Then we'll see how that gets assembled into geometry. After that, we'll fire up the computational engine and, finally, watch as the laws of physics just emerge, all as an inevitable consequence. Okay, first things first. Every language needs an alphabet, right? Well, according to DASHI, the language of reality is no different. But, spoiler alert, it's probably not what you're thinking. You see, the most fundamental building blocks aren't bits, zeros and ones. They're trits. The entire system is built on what's called a balanced ternary alphabet, -1, 0, and +1. This right here is the absolute foundation for everything else that's going to follow. And these states have really profound physical meanings. +1 is like an active excitation. It's a something. 0 is the vacuum, or nothing. And -1 is the conjugate excitation, a perfect anti-something. The idea here is that our whole universe is built from just these three simple states. And this is where things get really interesting and kind of messes with your head. In our digital world, we think in binary. But in DASHI, binary, that simple distinction between something and nothing, is actually a secondary property. You need this richer, three-part system first just to even define what binary is. It's a totally different way of thinking about information at its most basic level. Okay, so we've got our three-letter alphabet. Now, let's move on to the next stage of the pipeline and see how this actually builds the geometric foundation of reality. We're going from simple states to actual physical structures. And the assembly process follows this really clear, logical hierarchy. You start with three primitives, and they form a minimal relationship, a line. Then you take three of those lines, that's 9 primitives, and they can form the first closed surface, a sheet. And then finally, you take 3 of those sheets, or 27 primitives, and they assemble into the first truly stable, self-contained unit, a cube. Let's just pause on that number for a second. 27. 3 times 3 times 3. This number turns out to be incredibly important. It's not arbitrary at all. It's really the key to this whole structure. So what does that mean? Well, the crucial point is this. This 27-part cube is the smallest possible shape that is completely self-consistent. It doesn't need anything outside of itself to be stable. Every single part constrains every other part, creating this perfectly balanced, tiny little building block of geometric reality. All right, so we've got our building blocks, these perfect little 27 voxel cubes. But so what? They're just sitting there. How do they actually do anything? Well, this next stage in our pipeline is the engine. These are the rules of the computation, the dynamics that are going to breathe fire into the geometry. The first rule of the engine is basically a cosmic quality control check. It's called existential completion. So imagine you're building one of these cubes. If you've only placed, say, 18 of the 27 pieces, the system asks a very simple question. Is it even possible to finish this cube legally? And if the answer is no, the entire partial structure is just eliminated. It's a way of constantly pruning away impossible realities before they can even get started. The second rule makes sure the system's logic is absolutely rock solid. It's called monotone constraint propagation, and it basically means you can't cheat. You can't fix a mistake by just adding more complexity. Once a contradiction, a broken rule, shows up, it's there for good. This guarantees the whole system is honest and consistent as it evolves. And the final piece of the engine is what drives it all to a conclusion. Ultrametric contraction is a mathematical process that forces the entire system to converge toward one single unique answer, what's known as a fixed point. Think of it like a funnel that relentlessly shrinks all the possibilities down until only this one final, most stable closure state is left. And I really want to be clear about this because it's a huge point. That 27 voxel cube isn't just a convenient example of a shape. It is the engine. Each one of these cubes is a tiny computer, a semantic closure machine that's running these rules. And the collective output of all of these tiny computations is what we end up perceiving as the laws of physics. So this brings us to the final stage of the pipeline, which is really the payoff. We've gone from a simple three-letter alphabet all the way to a geometric engine. So what does that engine compute? This is where our familiar physical world finally shows up. This is just incredible. In DASHI, space and time are not starting assumptions. They're outputs of the system. The computation produces this ordered structure of events. Some events are causally linked, one causing the next in a chain. The system interprets these chains as time-like. Other events happen in parallel with no causal link. Those become space-like. The very fabric of space-time just emerges. And this just shows you how deterministic this whole process is. Have you ever wondered why we live in a universe with 3 dimensions of space and 1 of time? Well, DASHI's answer is pretty blunt, because it's the only stable solution. The computational engine literally tests all the possible dimensional signatures, and it finds that only the 3,1 signature, our spacetime, leads to a stable, consistent system. All the others are just mathematically pruned away. And maybe the most mind-bending result of all is where the arrow of time comes from. Why does time only move forward? In DASHI, time is just the universe constantly looking for simplicity. It's a principle called minimum description length descent. The universe is always computing a more compressed, more efficient version of itself. Our perception of time moving forward is simply us experiencing this relentless cosmic drive toward informational simplicity. So let's step back for a second. If DASHI's ideas hold up, what does this all mean for physics? Well, probably the best way to see that is to put it side by side with the reigning champion of theories of everything, string theory. And when you look at them together, the contrast is just stark. String theory requires a bunch of extra hidden dimensions. DASHI says those are unstable and get ruled out by the computation. String theory requires fundamental vibrating strings. In DASHI, there are no fundamental objects other than those 3 little primitives. But most importantly, where string theory assumes a geometric background and has to tune symmetries to match reality, DASHI argues that both the geometry and the symmetry are forced outcomes of the computation. It really does present itself as a radically simpler alternative. At the end of the day, this entire massive idea can be boiled down to this one powerful sentence. It says spacetime isn't the stage where the play happens, it's the final act of the play itself. It is the one unique, stable result, the fixed point, of a computation that's run on an engine made of 27 part cubes, which are built from an alphabet of just 3 states. It's a complete vision, from the absolute bottom to the top. And that leaves us with one final, pretty profound thought. If our entire universe, with all of its elegant laws and incredible structures, is really the output of a computation, it kind of makes you wonder, doesn't it? What was the original question?